Next, let's look at how to determine horizontal asymptotes of a function. So we're looking at the function f of x equal to 3x squared all divided by 6x squared plus x. So here we do have a rational function. Both our numerator and denominator are polynomial functions. Now, to determine any horizontal asymptote, we think about what is happening to our function as we approach infinity or as we approach negative infinity. So let's begin by taking a look at the graph of this function. And so let's look at what is happening as we approach positive infinity. As x gets larger and larger and larger, what is happening to our function? It looks like our function is approaching some value. And if we were to guess, we'd probably guess 1/2. And then similarly, as we approach negative infinity, so we're getting more and more negative, what is happening to our function? And it looks like our function is also approaching 1/2 as we go off to negative infinity. Now I want to point out that I have the line y equals 1/2 graphed on this xy axis as a dotted blue line. Now it's important to understand that that dotted line is not actually part of the graph of the function. It is just plotted on there so that we can visually see what our function is approaching. It's approaching that dotted line. So if we were given the graph of this function, we could look at it and we could say, well, hey, we have a horizontal asymptote at the line y equals 1/2. But now, what if we don't have the graph of the function and we want to determine the horizontal asymptote algebraically by just looking at the equation of the function? To do that, we look at the degree of the polynomial in the numerator, and we look at the degree of the polynomial in the denominator, and we compare those degrees. So here, the degree of the numerator is 2. Now recall that to determine the degree of a polynomial, we look at the highest exponent. Looking at the denominator, the degree of that polynomial is also 2. So the degree of the numerator and the denominator are equal. Anytime the degree of the numerator and the degree of the denominator equal each other, then we have a horizontal asymptote at the line y equals a over b, where a over b is the ratio of the leading coefficients of the numerator and the denominator. So in this case, looking at the numerator, the leading coefficient is 3. And if we look at the denominator, the leading coefficient is 6. So this reduces to 1/2. So we have a horizontal asymptote at the line y equals 1/2. In this next example, we also want to determine the horizontal asymptote of the function. So we're going to do the same thing. We're going to look at the degree of the numerator versus the degree of the denominator. The degree of the numerator in this case is 1. The largest exponent in the numerator is 1. The degree of the denominator is 3. So now we fall into the case of the degree of the numerator being less than the degree of the denominator. When this happens, then the line y equal to 0, which is also the x-axis, is our horizontal asymptote. And if we look at a graph of our rational function here, we do see that we have a horizontal asymptote at the line y equals 0. As our x values go to positive infinity, as we get larger and larger, we do see that our function is approaching that line y equals 0. Similarly, as our x values go off to negative infinity, we see that our function is approaching that line y equals 0.